convert over this semester. And we'll do this first before we finish up our lab. And try to give Bernard time to get here. So we're going to try to convert over the testing station and the process station, our module, which are the second one beside the distribution, which is the one that I've already done. So the first one is probably the hardest one to understand, and this is the actual control panel that's on the front. And what we have 4 push buttons on there. Yes, I just.
I know we got it.
So we have, this shows us what each button is, by the way. So these, we have lights within the push button, so that these are actually have little lights on them. So we have 2 circuits coming into each push button. One is the light that shows us when we hit it, and of course the other one will be the push button itself. So P1 is the light inside the start button, and then P2 is the light within the reset button. The stop button doesn't have a light. And then we got 2 other lights we call Q1 and Q2. Are y'all on the same page I'm on? Okay. And these are the 2 white lights that's right below the push button panel. We'll use those. I think I'm using them for each stop, and we'll show you all that. Then this comes up and connects to the connector that's on the actual. We used to call them Centronics connectors, but I don't know if they're the same thing, if they still call them that. And the printers, you think you cornered the market, you don't evolve with the market. Does that make sense? So eventually Centronics wasn't keeping up with the market, so they got left out. And when the printer first came out, there wasn't a set interface for the printer. There was a set interface for the computer. There was a 24-pin DIN connector on the back of the computer. And the standard was IEEE 1284. Never forget it. And that was on the back of the printer. It was a big old. This is for USB. This is when the printers were actually parallel. So the computer used to have a parallel port on the back of the computer that they called the printer port, but it was a parallel port. We used to reprogram it and use it for all different types of things. But there was no standard connector for the printer, no industry standard connector for the printer. So if you bought a printer, it had to come with the cable. I understand that. So eventually Centronics came out with an open technology connector that was called the Centronics plug, and this was it right here. And I'd have to look up and see. But basically, they'll come and get you one. Connector. It's in a D shape, so they took some of the features of the DIN connectors, and they put that in there so you can't plug the thing in there backwards. Okay. And this is the cable that both the Festo line and the Amatro line uses to connect between the PLC and the computer. And that would be this guy right here. So this is the one that'll run down to the PLC, to the mount for the PLC. And then of course the next one, this is the first one. And the first one, notice it's the same thing. It's just for some reason they split up the drawing for the lights and then the actual push buttons. And we don't give a label on which one these are. So we have switch one. These are momentary contact push buttons. Which this is the international symbol for a normally open push button. This is the international symbol for a normally closed push button. Let's see what we're talking about. So the normally closed push button has this little L shape on it, and that makes it normally open. This guy, I'm not sure where it's at. This is an indented push button. So I don't know what's being used. Where does it go to? And then S4, these are momentary. So this little indentation means that if you push it in, it's gonna hold. Oh, I know what that is. That's the key switch. So that's the switch that we change it between manual and auto. And I think I told you on this one, when you put it on manual, it runs on Festo line, the way the PLCs are programmed, it runs through one entire cycle. Where on the Amatrol, if we put it on manual, we can single step it. So this one's a little harder to see the sequence. Are we okay? Any questions on that? The next, we have the prints on the, we'll look at the testing station next. We're not giving out the pneumatics because basically we're how to connect the PLC, right? So this is the other connector. So this is the connector on the actual interface board that's got the terminal strips on it. And of course, what are these symbols? What's this a symbol for? First one on the left. That's a capacitive sensor, right? And it senses solids, just about all solids and some liquids. This is, well, this is not retroreflective because they have a transmitter and receiver. So this is a through the beam. Yeah. Notice this guy right here shows arrows. I can't see them on mine. Can y'all see them on yours? One of them should show, one of them shows arrows pointing out. And then somewhere we need one with arrows pointing in. These are Hall effect because they have 3 wires. A reed switch will only have 2 wires, right? Huh?
One, 3 wires.
Well, they all communicate, but the problem with reed switches don't have to be powered up. So what you'll do, if it's sourcing, if you're sourcing, then a reed switch will have 1 wire here, and then this wire will go directly to the PLC. A 3-wire sensor, which means it's an electronic sensor. So a Hall effect is not an electronic sensor. A Hall effect is just the switch that's activated by a magnet, a permanent magnet. Did I say reed switch on that one? A reed switch does that. A Hall effect is an electronic device, so it's got to be powered up. So notice it's a 3-wire sensor, so it's got 1 lead that comes off and goes back to 24 volts. And then it's got the other lead that goes back to 0 volts. And then it's got the 3rd lead that comes over here, and this goes to one of our inputs on our PLC. And that's what the I7 is. That's not I7 on the PLC. It might be, but it's I7 on the terminal board. That makes sense? Okay? It's I. No, I'm sorry. This is I4, right? Yeah. It would be pin 17, but it's going to be signal what? I4 on the terminal board. What's that? Yeah, so here's the actual input on the terminal board. Well, this is definitely an I. You're right, this is a 1. But this is an I, right? You okay? And then the next one, this, by the way, on the left, this one right here, this is the through the beam that connects the two modules together. You understand? So on the Amatrol line, they have DB9 connectors or cables that connect the sections together, the gray cables. What they do on the Festo line is they connect them together with through the beam modules. Okay? So this would be on the next one. This is an output. So what are these assembled for? This is assembled for a directional control valve. Okay. This is the actual valve center in the center, and these are the solenoids right here that shift the spool inside the valve. Are we okay? Yes or no? So this is at least a 2-position valve. This one has these two have spring returns on them. So we use a solenoid to shift the spool in one direction, and then it uses a spring to shift it back. We okay there? Now this is what the Amatrol line makes, but the Amatrol line is manually operated with a spring return. You've seen those, right? I'm going to go get one. You know what I'm talking about? Yes, no? Huh? Yeah. I don't know what the relays are called, but this would be K1. And these right here might be K2. And then our motor is connected right here. So if I wanted to run in one direction, then I'll come up here and I'll close these two contacts like this. Huh? Yeah. So what would happen is the minus would come up. If this is minus, then it's going to go through the armature in that direction and cause it to run one way, right? And this is really, really standard for controlling the direction of DC motors. For one thing, if you don't energize both of them, the motor stops, right? You understand? So we don't plug the motor. And then if we close K2, then current flow is going to be in this direction. and back up to the positive. So this is and you can see how I got the name H control because, and this could be done with solid state. Here they're doing it with relays. So that's on the Dremel. So the Dremel comes down and comes back up, right? So let's go ahead and we'll take the prints and let's go over here and try to